Hi, my name is Sean Donegan. My topic was CAD, Computer-Aided Design, and Creativity. Introduction. Since its invention in the late 1970s, the results of CAD work have become increasingly prevalent in our society. CAD allows designers to design, build, and test products, including structures, without ever having to leave their desk. CAD is an integral component in many STEM-based curriculums and has become a staple in many industries such as automotive, architectural, and fashion. The purpose for my study is to establish to see if there is a link or a relationship between CAD and creativity, and to see if students who use CAD have better creative abilities and what that means in terms of their problem-solving skills. My research questions are as follows. Is there a positive correlation between CAD class and the students' resulting creative abilities when given a design and problem-solving task? 2. How do students feel about CAD as a problem-solving tool? And 3. Do students feel more creative when designing on the computer versus traditional paper and pencil style drafting and design? Sampling. 50 participants will be selected to participate in the study. There will be two populations of 9th graders from which the participants are drawn from, those who have taken CAD class in 9th grade and those who have not taken CAD class. In 8th grade, all students in our school have to take general technology in which general traditional drafting is taught. So all students will have a general introduction to paper-based drafting, design, and problem solving. Simple random sampling will be used to select 25 students from each population. In the event a student wishes not to participate, another student will be chosen randomly. Procedure. We're going to use mixed methodology here. The quantitative approach will be a student questionnaire or survey to gauge how students feel about CAD as a problem-solving tool. This will be phase 2. Phase 1 will be a qualitative approach, and we'll use a design task to gauge the creativity and problem-solving skills of CAD versus non-CAD students. Procedure. The study will be comprised of two parts, phase 1 and phase 2, a performance task and a 20-question survey questionnaire. All students will partake in the performance task, phase 1, but only students who have taken CAD class will participate in phase 2, the survey or questionnaire. Phase 1, performance task. The performance task will happen during normal class times, but in two different environments. CAD students will complete the performance task during CAD class. Non-CAD students will take the performance task in their science class, in which I will be present. The informed design process of technology closely mirrors the scientific method taught in science classrooms nationwide, which allows both populations to participate in the performance task in a natural setting that is fit for the task. In both tasks, students will be asked to brainstorm, design, draw, and then construct a freestanding tower using only fun-sized marshmallows and spaghetti. All students will have to make a 3D drawing of their work. However, CAD students will have the option to design their towers in the computer using CAD. All students will get the same amount of time and building materials to complete the performance task. Phase 2, survey or questionnaire. It should be noted that the same 25 students who participated in phase 1 will also participate in phase 2. This will be done in CAD class as well, but on another day. The questionnaire will gauge their thoughts and perceptions about CAD as a creative problem-solving tool. This will also be done in CAD again, but on a different day. Data collection. Phase 1, performance task. Through the observation of the performance task, field notes will be taken. Descriptive field notes will capture, mostly through words, what the students were saying, did, and how they acted during the task. At the same time, reflective field notes will be collected based on the researcher, myself, feelings, speculations, ideas, and possible emerging patterns. Since the performance task will take roughly 30 minutes, there will be ample time to write down observations and field notes. Phase 2, survey or questionnaire. Again, only students who have taken CAD will participate in the 20-question survey. Students will be given an entire class to complete the survey if needed. The survey will be printed, handed out to the students, and their responses will be recorded on a Scantron sheet, which can be recorded electronically. The data analysis for Phase 1, performance task. The observations of the performance task will yield a large amount of descriptive and reflective notes. In order to analyze and synthesize the data, the field notes will have to be reviewed and examined thoroughly. Through this examination, emerging patterns and conditions will be identified when comparing the two populations. Phase 2. Questionnaires will be coded in a manner that works with a Scantron sheet, responses 1 through 5. A Likert scale will be used to measure the questionnaire. Responses will be as follows. 1. Strongly disagree. 2. Disagree. 3. Neither agree nor disagree. 4. Agree. 5. Strongly agree. Using Scantron sheets and the corresponding scoring machine, the responses to each item on the questionnaire can be tallied and shown numerically. Generalizations and patterns can be identified from the Scantron results. Limitations and weaknesses. Observations. Because the behaviors will be happening inside the classroom, any behaviors that occur quickly or are not noticed may be missed or not even recorded in the field notes. Also, my presence or the presence of the researcher may have a resulting effect on the behavior of the participants. Surveys. Surveys and questionnaires do not generally allow for the probing of additional information, that is, information not asked in the survey. Some students also do not record honest answers on surveys and instead may answer the survey based on what they think the researcher, myself, would like to see. Sampling. Simple sampling is a very representative of the general population, but does require a lot of time to identify and number each member of the population from which the samples will be selected. From our textbook, it was also shown that traditional sample random sampling has a larger sampling error than stratified sampling techniques. Well, that about sums up my research proposal. Thank you for listening.